So I I will admit I procrastinated making slides for this for quite a while, and I did eventually get a slide deck put together. Um, but I kind of decided yesterday, you know what, I'm going to do this whole presentation in the terminal anyway. So the thing I want to talk about is how Shopify is using Nix to power its monorepo. And I'm going to show you first. I'll go into our monorepo root here, and I'm going to run tech run this thing. And here's my slides. So we're going to talk about Tectonix. So Shopify in 2024 decided we were going to be a monorepo company, and this is kind of the story of how that came to be. So I guess by way of introduction, I'm a principal engineer at Shopify. I've been around for 14 years now and been responsible for most of our generations of developer tools. Some of you might remember me from NixCon 2019 in Czechia. I gave a talk there about how Shopify was adopting Nix to power its developer tools. We had been kind of gutting our existing kind of convergent tool. So we have this tool called Dev. We did that, and we still do actually, that operated a little bit like Chef or Puppet. And we thought we would replace the internals with Nix to deal with these problems you start getting to when you have 1,000 developers and they can all break their machines in fascinating different ways. Nix solved that problem quite nicely, but we stopped. This talk is three parts. There's some context about our journey with Nix and the monorepo adventure, and then two technical bits, Tectonix and Tectonix. So we were hollowing out Dev to replace it with Nix. The promise is this reproducibility across thousands of machines. The problems we ran into are like, Nix is really hard. It's hard for me. It was hard for me to learn to build this stuff. It was double hard to teach to everybody in the organization when they would run into the rough edges with it. Nix also wants you to go all in. It's very difficult to use Nix in a kind of piecemeal way, or at least I was not up for the challenge in 2019. And the organization wasn't really willing to bite the bullet to go all in on Nix. I wanted to kind of sprinkle Nix a little bit to power our development environments in a way that, at the time at least, I felt like Nix was fighting me on that. We tried to paper over all the sharp edges, and ultimately, I wasn't able to pull it off. Made some kind of strategic errors that annoyed some critical people, and we decided, you know what, we're done with this project. We're going to roll it back. This was not the thing to do at the time. So, was that the wrong decision? I think not really. It was, at the time, the effort reward for us was, the reward was kind of there, but the effort was so high. And we were starting to get to this point where we were going to have to teach our users more about Nix, and they just wanted to ship their code. It was a pretty high burden to subject them to at the time. So Nix, as you're all quite aware, has a fairly punishing learning curve, and we didn't feel like there were great resources to teach people Nix at the time. So we put it aside. But then 2024 came around. This is maybe 4 years after we dropped it. We were sitting around at a very large room in Toronto with something like 6,000 people or something. And it was hack days. So company-wide sort of hackathon for 2 days. Chatting with Toby, the CEO. Toby is an engineer at heart. And he gets very into technical details around the company, and especially things that are like very obsessively nerdy, such as Nix. He says to me, you know what I really regret? Killing that Nix project. I was like, okay, great. But by the end of the day, we had decided, using this kind of like hack days energy and all of the sort of ambition in the air, you know what? Like, we actually have to be more ambitious about our developer tools here. What we're going to do is, like, right now we're deciding that we're readopting Nix for our development environments. We're going back to local development. And this one is a little bit, there's some context here that I'm not going to fully fill in, but we had some cloud development environments that led to these really artisanal configurations that it's not super relevant to the story, but dropping that put us closer towards the Nix dream too, kind of. And we were becoming a monorepo company. This was arguably actually the biggest of the three things. This is a pretty consequential technical decision, and we decided we were going to sort of jump in on that one with both feet. And a sort of consequence we derived from this one is, well, if we're using Nix for some things, we may as well use Nix to be the build system for the monorepo as well. So this is the path we took. So why was this a good idea in 2024, but not in 2020? Honestly, it's that Claude will write the code for us now. Like, this whole thing of it being a pain in the ass to learn Nix being complex, running into these errors that you just feel sort of stonewalled by and unable to get past. I notice, I can easily remember the days of feeling this way myself, but I notice it so clearly with users when they're not leaning into these tools. Is like, Nix has errors that can feel fairly disempowering, but it sort of doesn't matter anymore. If you toss Claude at these things, your problem is solved. They can write the code for you if you don't understand, right? They might not necessarily be able to implement the guts of this system for you, but you can certainly craft the system in a way that your users can unblock themselves. The learning curve now kind of is someone else's problem. So this is what we basically realized, is software is free now. And this isn't just about Nix, but I do think Nix disproportionately benefits from this, because all of the complexity that made Nix hard for humans sort of doesn't matter, but all of the benefits that Nix has always had, that we sort of adopt Nix despite these horrible complexity trade-offs because of these incredible benefits that have still somehow outweighed the cost. The equation tips so far in Nix's favor, in my opinion. So monorepos also have relevant advantages here. When all your code is in one place, you can just drop Claude or whatever at the root of your monorepo, and it, as long as you coach it correctly, knows everything about everything. You can make cross-cutting changes happen in one pull request. There's no negotiating across API boundaries as long as we're talking about build time dependencies. You can atomically change publishers and consumers of a library in one go. This makes it really easy to do cross-cutting refactors in a way that is difficult, or more difficult, at least in poly repos. There's another thing that has been like, raise your hand if Git work trees were a part of your life a year ago. Right? A few, yeah. 20%, 25%. Yeah, like, who uses Git work trees now? So like 75%. So this is something that, well, especially in a monorepo with agents, you really start wanting work trees. And I find Nix lends itself really well to work tree style development too, if you're using it for development environments, because it depends a lot on how you build your development environments, but the way we were doing it before, at least, had a lot of things that would be sort of wastefully duplicated across work trees. And now with Nix, this is just a symlink to a thing that you already have in the Nix store, and it takes whatever number of milliseconds. So this is cool. The dream basically is anywhere in any work tree, in any zone. We call them zones. Fun story about our monorepo. You want to divide a monorepo up into some kind of package, right? Package would be a good word, but Nix definitely already claimed the word package, and we cared about not conflicting with Nix. Every other good word for what you might decide to carve up a monorepo into was taken by something important in Shopify, so zones is what we call them. It's fine, I promise. So the Yeah, Fareed. Yeah, shoot.
Where you guys with private or let's say bring your own gear. You would not see a delay. And like five away, there's a say grape and I could be brave, but
Yeah, it's some of this is still. So the question is, Nix doesn't exactly describe like Nix is a little bit bring your own build system. How are we doing the build systems for the various language ecosystems? The answer is it's a little bit ad hoc, and we get to punt on this question a little bit because being a predominantly Ruby company, like where most of the biggest projects care mostly about Ruby, which famously does not have anything resembling a build step, we get to sort of let this crystallize a little bit later in the process than other companies would. So the sort of philosophy we're trying to apply here is we would like to, as much as possible, preserve the user experience of the existing ecosystem package managers and wrap and patch them in whatever way it takes to make them collaborate with Nix to do whatever it seems to be that we need to. But yeah, the dream is basically we run dev up, which then calls Nix to do something, and we get instantly a development environment from wherever. So let's talk about how we made that happen. Part 2, Tectonix. So our Git repo is currently 30 gigabytes. This is the Git directory itself. Even after splitting out everything on import that exceeded some size threshold to be an LFS file, it's fairly polyglot. It's like I've mentioned we're dominantly Ruby, but there is a whole lot of TypeScript, Rust, Go, some C++, you name it. There's a little bit. The thing about a 30 gigabyte Git directory and over 1 million files is the Git index does not love that if all of that is in your checkout. Every operation starts to become miserably slow. A Git checkout can take upwards of 20 seconds. Git status might take 7. So we use sparse-checkout. And we specifically use sparse-checkout in cone mode. The only reason we're actually able to stay on Git here is that Microsoft front ran us a little bit on this by making some performance patches to Git a couple years back to make it sort of borderline reasonable for them to put Office and Windows in Git. So we've benefited a huge amount from this, and we're using sparse checkout in cone mode. And what cone mode is basically you specify a subtree root, and then everything under that subtree appears in your checkout. Everything that isn't in one of those patterns does not appear in your checkout. So that works great, especially because we sort of carve up our monorepo into these, what are the same as cone shapes called zones. So here's the challenge, though. We're a Nix-based monorepo. You are some code in zone A. You want to evaluate some Nix code that depends on something in zone B. Zone B is not checked out. What do? Right? You can't just import /b/default.nix. So here's the false path. Our first solution was fairly hideous. The basic idea was we're going to use import from derivation to just like call git show to get a file called zone.nix from that zone for every zone that we want to depend on, every build we want to do. It totally worked, but it was miserably slow. But we kind of built this with a philosophy of like, first we're going to make it work. We're going to design the user experience that we know should be possible. Then we're going to figure out how the heck we're going to make it fast later. So that's what we did, and we limped along with that for months, and it was sort of fine. This is actually the code that made that work, and I'm just going to linger on this for a little while because it's hideous. So at the bottom you'll see git show. This was a function that got called kind of indirectly from some other places, and really all it did was git show object to out, right? But you can see the build inputs has world get. World get in the middle. What this is we're going to specifically call git with a git config that passes a git directory of the prescribed clone location of world, our repo. But home, right? This repo, the prescribed location is under the user's home directory. And of course, Nix builds run as the Nix daemon. So we don't know what the home directory is. So we also had to do this terrible black magic to figure out what the user's home directory is, which was, it turns out if you stat dev console, you can figure out who is logged in. So please never do this. Anyway, that worked. We also actually had to set an ACL on the user's home directory so that Nix would be able to traverse it. Just don't do this. This is a case study in what to never do. So that worked, but now how do we make it fast, right? Maybe I've heard dynamic derivations maybe sometimes replace IFD. Is that relevant? I don't know. Disable SIP and use fuse, I guess. I don't want to make even more enemies in the security team. Maybe we could patch Nix. So I kind of realized software is free now, so why don't we just patch Nix? And that is what Tectonix became. It turned out this was actually really easy. So what we have now is we have our little fork of Nix where we pass another flag, Tectonix git SHA. And then we have some new built-ins. In this case, one is called, I tried to make these very unappealing for our users to call directly. You can see, anyway, unsafe Tectonix internal zone source. So we pass it a zone path. Our zone paths start with double slash, like a Bazel monorepo or whatever. And this gives us basically an accessor to the source. We can pull a file out of it. We can import it much faster, way better. And this gives us the imported file. Big improvement. Here are the built-ins we added. This doesn't really matter, but just maybe this gives you a sense of like the flavor of what we did. We have a manifest at the root of the repo that sort of just enumerates all the zones. And so we have that, and then an inverted version of it, and then a thing that gives us a source given a zone, and then some other stuff that doesn't really matter for the purposes of this talk. Actually, one thing that maybe does matter is you'll see a couple things here like sparse checkout routes and dirty zones. One of the things that Tectonix does is it sort of flexibly decides whether it's going to pull the source of a zone from your local checkout or the Git directory based on basically whether there are uncommitted changes. So it tries to be intelligent about building from the local checkout. Yeah, Fareed? Yeah. Yeah, so the question is, we're just mostly concerned with providing environments, so couldn't we have stopped before Nix build? So one of the things is that the monorepo is sort of self-describing, self-implementing. So a lot of our tools are actually zones in world. So they are built as builds and then provided as the actual like profile of tools that gets installed as the base layer here. Some of them come from, a lot of them come from Nix packages, but a lot of them are actually like monorepo builds. So one question that came up, actually repeatedly because Toby kept asking me, was why not use flakes? And it sounds like a very sensible question. Like flakes are the thing, why don't we use them? They seem like they're maybe shaped like this problem. So we had two choices basically if we wanted to use flakes. We could put one flake at the root, but then maybe I didn't spend enough time thinking about this, but this doesn't feel like it makes sense to me because you certainly encapsulate all of your inputs nicely, but then you sort of, it doesn't feel like you've gained a lot really because you're not solving your like, your problem. I think there's maybe like sub flakes or something now. Maybe I could have looked into that. The other thing is like if you have one flake per zone, that totally feels like it solves this. And it kind of does. But the problem is then you have, every time you want a zone to depend on another zone, you have an input registered there and that has a hash. So then if you change something that's like deeply transitively dependent on, you have spidering hash updates all across the repo, possibly including a bunch of files that aren't even in your sparse checkout. So you would end up with, especially as you grow to be a more sort of like deeply in-webbed kind of heavily depended monorepo, you get to this point where you have a fairly ugly kind of pull request process where you get these hash updates scattered everywhere. All this on top of the sparse checkout conundrum, which like I don't think we'd easily be able to make flakes handle the fact that the flakes they're depending on are just not there. So the kind of key insight here is we're building a trunk-based monorepo. Everything depends on the concurrent revision. So if you're operating at revision head and you're depending on zone ABC, you are depending on zone ABC at version head, and there is no other option. So in this context, Git's Merkle tree already provides consistency. You don't need a hash to assert that you're like maintaining your version integrity. It's just implied by the fact that you're operating at the same Git commit. Flakes would duplicate this. So I made that case, and then Toby pushed back again. He says, well, that's fine, but flakes have lazy trees. It's like, it's a real shame to miss out on those. And having an engineer CEO is awesome most of the time, but it's really annoying when he's right. And so then I kind of, that really got to me because it was annoying. Like lazy trees are excellent, and I really wished we could have just had them. But I realized that I could just make them work in Tectonix, and I did. I just opened Claude and I said, can you make me have lazy trees? And it said yes. So that was surprising. So yeah, Tectonix is now a fork of Nix. And I mean, obviously that only worked because the lazy trees code was excellent. So thank you. But yeah, so Tectonix is now a fork of Nix. Really, it's a set of patches on top of determinate Nix that we just maintain because that's easy too. It has this sort of like monorepo SHA concept. You know what SHA you're on. It does all this Git object database integration with libgit too, which I don't exactly love, but Git doesn't do a good job of being a library, so that's what we're stuck with. It does a lot of caching to make it all fast, and it has lazy trees. Delightful. I sort of mental model it to myself as like what if flakes, but designed exactly for our monorepo. It's like, it's kind of open source, but it won't be directly useful for you, but I don't know, maybe it inspires something. So then the other part is Tectonix. So it used to be the case that I thought of Tectonix as two things, the kind of like guts of our monorepo and the other thing I'm about to describe. The guts of the monorepo sort of got extracted out into Tectonix. And so what Tectonix is pretty much now is the build system, the module system. And there's a fun thing about this word that I just want to highlight. Tectonix is a triple entendre, which I'm super proud of because I accidentally woke up in the middle of the night and had this idea in a dream. So, yeah, it's like, our monorepo is called world. So it's, tectonic plates, the foundation of world. Also, tecton is the ancient Greek word for builder. It's a build system. And then very prosaically, Tectonix technically makes it a triple entendre, even if it's not a very exciting one. So it's a module system. Basically, this is, we use the NixOS module system, types, lib, bunch of stuff. But we define our own modules, kind of similar to devenv, quite honestly. Every zone has a zone.nix file. This configures everything like languages, dependencies, CI, development environment, and everything flows down through progressive refinement. So basically, what Tectonix does at the end of the day is there's a whole sort of progressively concrete level of options that you can assign that all bottom out in assigning to an attribute set called targets, which is just derivations. And everything you could possibly do with Tectonix from the sort of outside perspective is pulling out something from the targets attribute set. And that's just a build. So if I would run this command, tech is our orchestrator for Tectonix. So Tectonix is a Nix code base, but we don't suggest to people that they literally run the Nix command to build things. We re-expose it as this tech command, which has, I don't know, something like 15 subcommands, but the relevant ones to point to here that kind of give you the major mental model are build and run. So if I run this, tech build areas tools tech default, what this is going to do is it's going to build the module system for this areas tools tech zone, look up the targets attribute set, pull an item called default off of it, and then run nix build on that basically, and then give you this thing back out. So an interesting thing about this, though, is this works, I mean, as I've kind of alluded to, this works regardless of whether or not the zone is checked out, because it'll read directly into the object database using lazy trees. But another thing is it actually works even if world isn't cloned on your disk. And that's a little bit surprising given the mental model I've handed you so far. The way that works is tech actually collaborates with this other piece of software called Windex. And what Windex does is it's a cache that gets filled by our continuous build servers that takes this input of a zone ID. Zones have IDs too. It doesn't matter. Just think of it as a zone path. Target name, get SHA, platform identifier. And it's basically just a key value store that resolves that to a Nix store path. So given this output, we can just try to like Nix store realize that and presumably fetch it from our binary cache. So knowing these 4 facts about what you want, which are totally inferable from the command line where I ran tech build, you can check. This is nice too because it short circuits the whole Nix eval step. So now rather than being like 2 to 7 seconds or whatever, it's 50 milliseconds. So it's filled by continuous build servers, no checkout needed. If it's been built at that SHA, Windex has it. So there are, I made this up for this slide, but I think I stand by it. 3 principles that I want to hold to in Tectonix. So meeting the user where they are, letting the agent write the code in the zone.nix for the most part, and feeding back on variants. So let's talk about those. So number 1, meeting the user where they are. If you ask a user to like describe a zone, especially like a small project, right? Like if somebody just writes a library and it's like 100 lines of code and they did it in an hour because it was just sort of extracting a thing. If they describe to you what that thing is, they're going to be like, it's a Ruby library. There's nothing special about it, right? And so your config for that zone should look a lot like, it's a Ruby library. There's nothing special about it. Or even, simpler. We're playing around with a few different like high-level syntaxes here. The idea is what we want this file to represent is the intent, not the implementation. In a monorepo, you don't have to lock versions exactly because you don't have to deal with this whole like producer repo, consumer repo thing. You have atomic changes across the whole thing, and you have CI that can trigger across the entire repo when you change anything. So if bumping Nix packages breaks your MySQL, you can do this thing where you can actually just leave it fairly loosely specified, but then discover upon attempting to bump that you now have learned that you no longer had meant to just give me MySQL. You now had meant give me a specific version of MySQL. So there's this kind of like retrocausal intent thing going on where you can sort of discover that you actually had meant a different thing prior and now we pin it for you, right? And this gives you an interesting thing because you now, this sort of like calls forward to another point that I'll get to in a minute, but this gives you an interesting thing where you can sort of like see the increasing complexity of configs and treat that as a signal that like maybe this project has drifted and there's a sort of reunification of standards that we could do. This is the big one that has changed our attitudes about Nix this time around in 2024 and onward, is in before humans would write this file, and we had to be very careful with managing complexity exposure because we have thousands of users and we don't want to have to make them all learn Nix. But now basically we can say, you can write it if you want, but like, here are some Claude skills that will configure this project for you however you want. Just tell it what you want. Complexity doesn't matter, or it does, but it doesn't matter in the same way. We don't need to teach users Nix. We need to teach agents our module system. And that's a very different problem. So I'll kind of get to one little aspect of that soon. But the third principle is feeding back on variance. So the complexity that we see in these zone.nix files across our hundreds or thousands of zones is a signal. If there's a file that's just a couple lines, that means we have perfectly captured the pattern that represents what that project is trying to do. If it's high variance, if they have a ton of code, it's suspicious. It could mean the project is genuinely unusual. It could mean we, the tools team, failed to capture a pattern, or it could just mean that user had no idea what they were doing. In any of those three cases, it's probably good to at least attempt to reunify some of that. In some of these cases, you will have the genuinely unusual project, and you go, okay, this is actually fine. You're doing something weird, and it's good. We're not going to refactor this. But all these other cases are a signal that there's something not captured by the contract between your build system and your users. But this is all visible, queryable, all in the same repository, and it's very easy to make atomic refactors where you implement a library and refactor the consumer to use it in the same commit, and also prove that nothing has changed. So we can also make this queryable. And there's an interesting thing where NixOS has this options doc, options generation that's really cool. You can also generate a similar document that includes all of the current settings and the definition sites, declaration sites, the intermediate values that are all merged together. This is really cool. One thing that I'm kind of prototyping is, what if we evaluate this across all of the zones in the monorepo, compile it into a Parquet thing. Parquet, for those who don't know, is like a columnar kind of data store format. It lets you encode highly normalized, denormalized, I can never remember which one. Repeat all the data, right? And just like dump it all in a bunch of rows and then just query it with SQL. It's just sort of magic. You can say things like, give me all of the zones where it's, Ruby version 3.4.2 and higher than 1 CI parallelism or whatever, right? So this is kind of cool because now you can actually just generate that file, give Claude a skill to interact with it, and now you can ask questions about your whole monorepo and have this happen sort of magically, right? What zones depend on the deprecated money library? And that's now just a thing that Claude can figure out locally. So a lot of this was foresight, and some of it was a lucky bet. In 2024, when we were sitting around at that company summit, like the thing that was motivating this really was we were speculating about this future and how at some point in the next several years, it was likely to be the case that we were going to benefit a lot from AI writing a lot of our code. I think it came faster than we were anticipating, but we feel super lucky, or at least I feel super lucky, to have kind of made these choices at the time we did, because we're kind of right in this phase right now where we've shaken the snow globe and the snow is falling as we're like trying to figure out how to work with these new tools at the same time too. So I think like the preliminary results for us is I can say like Nix and monorepos both seem to be great choices for this era. And I definitely see Nix gaining ground in this ecosystem. I know we've all heard a lot about this over the last day and a half already, but it's like, it's so true that Nix is the perfect technology for the moment here. There's this effect though, where like when software becomes cheap to write, the thing that starts to matter is taste, right? Like the decisions about not can we build it, but like what actually should we build, and is this the right way to build it? Because software is free now. Nix and our monorepo are two parts, like the critical parts of making this actually true for us. Like stripping all of the toil out of our workflow so that we can focus on what we should build and whether it's the right shape. So we're building towards this world where we spin up an agent anywhere in world. Nix gives it an instant development environment, gets us to running the tests instantly. We have situational awareness. No onboarding, no tribal knowledge, no asking someone in Slack. It's just immediately productive. So that's the dream. We're getting there, and Nix and the monorepo thing have been critical in this. Yeah. Thank you. Fareed.
For repo based for capture in I use Kali.
Yeah. So we will have an application zone, and that'll be the part that the user is actively working on. It will have, in our case, often a gem file that will include gem like paths to libraries. And those will be when we run dev up or bundle install or whatever, that orchestrates Tectonix to build those into the Nix store it'll read from the Git object database unless they're on disk. So you can add them to your sparse checkout and work on them there. But by default, it's just like if you had a library that existed somewhere in rubygems.org, it's like the source is not super visible until you choose to make it visible to you. Yeah. It's both. Yeah, there's some sorcery here to just like make the ergonomics remain familiar while also allowing Nix to do the nice caching things for us. Yeah.
It's you for here is it's you out of that hit up your report adding them what be your term does.
Not really. I think if I had thought seriously about it, I would have suspected that my changes were going to be deep enough surgery that I would have tripped over it. But it felt so easy to fork it and so easy to maintain a fork that it didn't seem important. I'm trying to remember whether we enforce this. We don't have circular dependencies. We at least have not tripped over that yet. I cannot remember off the top of my head whether we enforce that continues to be true.
What are you asking about?
Yeah. Okay, so if we were not limited, okay, so the sparse checkout thing is actually funny because I was just working last night on the big problem is Git's index requires a lot of redundant work on every command. And I have a branch that I'm like working on to see like what if this is just a memory mapped file that doesn't require any translation? Can I actually get away with a full dense checkout? So we might actually be able to pivot to that if I can figure this out. But the thing that I would do if we did have that is I would get much more paranoid about sandboxing these zones so they can't talk to each other. Because right now we get to be a little bit lazy about that because the files don't all exist on disk. We are kind of doing a halfway Nix thing where it's not the case that everything operates in a Nix build. Of course, once it goes to our continuous build server and we build certain artifacts, those are done in a real Nix context. And so they won't have a checkout that they can cross-bleed across. But there would be some worry there. Other build systems, we had actually been trying to use Bazel for our, especially TypeScript, for about a year before we had this sort of 2024 moment, and had been largely unsuccessful with it because I think Bazel, even more than Nix, really insisted on you like Bazelifying your whole thing at one kind of cutover moment. and that was a difficult thing for us to like A, do, and B, buy into the concept of wanting to do. Yeah, and like I kind of alluded to this before, because Shopify is such a Ruby dominant company, like we get to be a little bit lazier about our build systems. There are ecosystems that are more and less annoyed by this, but we don't have any like ultra massive compiled projects that need like really significant like distributed build infrastructure. It's possible we will in the future, but we have kind of some runway to build that as we grow into it. Yeah. Yeah. So I'm sorry, I've forgotten to repeat so many questions. Interaction with other build systems. So yeah, this is all kind of done slightly ad hoc. Like we're trying to use stuff that exists in Nix packages when we can, but we are like, I think the stuff that exists in Nix packages by and large isn't excellent for like live development environments when you want to like convert a cargo toml into like a set of derivations. So I hope that the shape that we settle on some of this stuff for can be contributed back in some way, because what we're trying to build, which is all sort of in flight right now, is like a way that sort of flexes from development, having this like familiar ergonomic and like not really compromising on any major workflows there, but then scales up to a sensible production build in a way that doesn't really cut corners there either. So it's an interesting thing to try to. I think we have time for one more quick question. Probably not in 1 minute. uh, I I'll try to encourage the guys working on this to maybe write a blog post about it. I think that could be helpful. Yeah. I think that's it.